The problem is to find the force on the system that will produce an acceleration of 0.2 meter per second square. Two blocks, they are attached by a string which goes over a pulley, which in turn is attached to the wall. The blocks have a coefficient of friction of 0.2, and the coefficient of friction at the lower surface is also 0.2. What is the force required to produce this acceleration? This is the problem. Now, in order to solve this problem, we first concentrate on the mass m2. For m2, we write the equation tension minus mu times m2 into g, which is the force due to friction. M2 into g is the normal reaction, and mu times normal reaction is the friction, is equal to m2 into a. Now we write for the block M1. For the block M1, F minus T minus the frictional force at the top of the block M1, which will be mu times M2 into G, and the frictional force at the bottom of the block M1, which will be mu times M1 plus M2 into G, should be equal to M1 into A. This is our equation 1, and this is our equation 2. At the bottom of the block M1, the normal reaction would be due to the weight of the block of mass M2 and the block M1. Therefore, this is the frictional force. Now we can put the values of mu M2 and A in the equation 1. So T minus 0.2 into 0.5 into 10, which we have taken as the value of G, would be equal to 0.5 into 0.2. So this gives us T minus 1.0 equal to 0.1. So that gives us T equal to 1.1 Newton. Now we can use this value of T in equation 2. So from equation 2, we write F minus 1.1 minus mu m2g is 1.0. We have already found this out. So this is 1.0, and this will be 0.2 multiplied by 1.5 multiply by 10 is equal to m1 is 1 into zero point 0.2. So this gives us the value of f, which is 1.1 plus 1.0 plus 3.0 plus 0.2. This gives us 5.3 Newton. Thank you for watching. If you have any queries or want to have any discussion, then you can contact me at the following email address: Dr. Atish Mazumdar @gmail.com.